Yeah, good evening all. This is Dr. Praveen, Associate Professor in School of Computer Science and Artificial Intelligence, SR University. Yeah, today I want to explain queues concept in linear data structures. In data structures, the very important concept is the queues and stacks. Okay, now the main objective of queues, what are the types of queues, why we learn queues, where we learn queues. These are the main motto in today's class. So now this is the main concept. Now going to take the what is the main queue is a linear data structure. You observe here, queue is the linear data structure. And now 1 second, please. Queue is the linear data structure. Yeah. Now queue follows first in, first out. See observe here, first in, first out. It means the first element is removed first or last in, last out order. Either first in, first out order, last in, last out order. Both are same, which means that element inserted first will be removed first, and the element inserted last will be removed last. So now, for example, this is the box you observe here. Now, in this one, we are inserting elements. These are all the elements. We have two endpoints are there. One endpoint is called front, another endpoint is called rear. Okay, when we are remove the elements through only front point. If you want to insert the elements, then we can use the rear. So the queue has contained two endpoints. One is called front, another one is called rear. So this is the symbolic representation of queues. Now insertion is called, the operation insertion is the Enqueue and deletion is the Dequeue. So actually in our normal programming we have to use the insertion and deletion. So in queue concept we can use Enqueue. Enqueue means inserting the elements into the queue. Dequeue means deleting elements from the queue. So now this is examples of the queues we observe here. Now railway ticket booking. The railway ticket booking in the teller is giving the tickets orderly. So orderly means first in, first out. Here we have three members are there. Now three members. So the first number is 1, second number is 2, third number is 3. Now these are maintained the order 1, 2, 3. So he is the first person. So the red shirt person is the first one. So the teller is giving the ticket for first person and it is removed from the queue list. And now after this one, the second person is the first. So he is taking ticket from the teller and he is also moving towards as well as we follow the map. So this is called the one example for the queue. And next here you take this is the entry point, this is the exit point. Okay, we have some people are there, only one entry and one exit. So she is the first person and she is the second. He is the second person, third person, and fourth person. Fourth person means he is the last person. So the last person is removed last. That is the last in, last out. First in, first out. Okay. And one more example in the traffic signal. In toll gate, we follow the sequence. So now this is the first one. So after exit of this bus and the second car will exit. So because it is also follow the first in first out manner. You observe here students. Now here one is the railway ticket booking, another one is the shopping mall, third one is the toll gate. And now what is the algorithm of the queue? The queue operations, how many operations we have? Two operations. And another operation is peak. And one more operation we have that is called the display. So total number of operations are 4 operations. One is One is Enqueue, second from Enqueue we write here. Enqueue, Dequeue, third one is peak. Peak means we remove the first element is displayed on your screen. And last one is the display. See, these are the four operations of the queue. Okay, now the first one is the Enqueue. It is important, like inserting the elements into the queue. So this is the algorithm you observe here. This is the algorithm for the Enqueue. The operation is name is Enqueue. Enqueue. Now Q, comma, n items. Q is the array, n is the elements, number of elements, and item, name, and rare. So if first of all we have to check the queue, whether the queue is empty or whether the queue is full. So first initially we have a here. This is the array. These are all the okay. Now this is front. This is rear. First initially front and rear. F equal to 0 or equal to 0. Front equal to 0 and rear equal to 0. So for example, if this is the n equal to, for example, 6, I want to take 6. Suppose rear equal to n minus 1. Rear equal to n minus 1. If rear equal to n minus 1. Now the queue is overflow. Why the queue is overflow? Okay, well, how many elements are there? What is the size of the queue? N is means 6. Now you start from 0, 0, 0 to 5. 0 to 5, how many elements? 6. So there is no possibility to insert new element into the queue. So this is the first condition to check whether the queue is empty or not, whether the queue is full or not. Observe here. If rear equal to n minus 1, rear is greater than n minus 1 or rear equal to n minus 1, there is no possibility to insert a new element, right? And for example, now front equal to 0. What do you mean by front equal to 0? Front equal to rear equal to minus 1. We take the another condition. This is one condition. And second condition is if front equal to rear equal to minus 1. Now what about this situation? Now front is minus 1 as well as rear equal to minus 1. Then the queue is empty, because whenever you start the program, whenever you start the application, initially front equal to minus 1, rear equal to minus 1. Okay, front equal to minus 1 and rear equal to minus 1. If both are equivalent to minus 1, then there is no elements into the queue. Means queue is the empty. Okay, clear? Is it clear? First we take the two conditions. One is front equal to rear equal to minus 1. The queue is empty. Another one is if rear equal to n minus 1 or rear is greater than rear by as well, then there is no possibility to insert elements. So now for example, front equal to minus 1, rear equal to minus 1. Now we are inserting the elements. So in this situation, we are inserting a new element. So here we come to this point, else, we write like else. After this statement, we write else. Now front equal to a of front or the q of front equal f equal to 0, n element. N means our element. Now f equal to 0, front equal to rear equal to minus, then f equal to 0, or as well as r equal to 0. So q of front equal to or q of f equal to element. What is the element? We are inserting some element that is reside in the first position. Okay, and r q of rear equal to element. As if you follow the one is q of rear equal to front equal to 0. So this is the where is this? This is the front, this is the rear, first position. So Q of rear equal to element or Q of front equal to element. If you wish. If you continue with the rear, then you have to use only rear. Q of rear equal to element. Now rear equal to rear plus 1. Front position is same. Front position is same. We are inserting the element. That's why rear equal to rear plus 1. Okay, this is the algorithm for the Enqueue. And next one is the Dequeue. See, observe here, and we have take some example. Now, what is n value? Initially, we take the n equal to 6. So, first f equal to r equal to -1. Enqueue. If f equal to r equal to -1, printf, you write the complete program. Here I want to write small. Now, else q of r equal to element. Here else f equal to 0, r equal to 0, q of rear equal to element. So this is f, this is r. So element, we are insert the element is suppose 5. Now r equal to, or better you write here plus rear. Plus rear. Or q of rear equal to element, rear plus. Your wish. Okay. So element is inserted. Again, I want to insert a new element. Next element. Front equal to rear equal to -1. No, this condition is failed. Then go to the else block. In else block, so better you have to write this one is here. You write here. Else go to the else block. Plus rear. What is the rear position? 0. Now plus 0 equal to 1. So the next element, for example, we are enter the next element is 10. We are enter R value. Front equal to same 0th position. Rear is incremented by 1. This is the Q operation, Q in Enqueue operation. And second operation is the Dequeue operation. What is Dequeue operation? Dequeue means deleting the element from the queue. Suppose same condition. If rear equal to -1, what about your queue? Rear equal to -1, then queue is empty. Otherwise we have some elements are there. So we want to remove that elements from the queue. So then we can use the simple, we write like this, void, sorry. Here we write this. Now rear equal to -1, then write queue is empty. Otherwise, set items to front to queue. Set items to front to queue means here we have write the, see, now this is the queue, whether the queue is empty. Now, yes, here go to the third step. In third step, if rear equal to front, one element is empty. Otherwise, for example, rear equal to -1, there is no elements in your queue. That is called the underflow. Otherwise, front value is incremented by 1. So front value is incremented by 1 means the first element is removed from the play queue. So our manner is the first in first out manner. So what about the first element? First element will be removed first. So that is the whole objective of the queue and objective of the Dequeue. And now coming to here, we have a small program by using the C++ void queue display. Suppose rear equal to -1, there is no elements in your queue. Otherwise, we have to print you start with the front up to end point. Now this is the, now front value equal to 0, rear value equal, for example, total we have 6 elements are there. So front value equal to 0, the rear value equal to 5. So you start from the front. So front equal to 0, I less than or equal to rear means I less than or equal to 5. I is incremented by 1. So initially A of front means A of 0. You print the first element and I value will be incremented by 1. I equal to I plus 1. So I equal to 1, 1 less than or equal to 5. Again the condition is satisfied. Then you print the second element, third element, nth element. Continue until rear. I equal to rear. So now Q animation for Enqueue. So this is the front, this is the rear first initially. So you observe here, initially front equal to rear equal to 0. So front equal to rear equal to 0. Then we can increment the elements. We are inserting the element, then rear value is increment by 1. Rear is greater than or equal to n minus 1, then there is no possibility to insert the new element. So front equal to minus 1, then your Q is empty. So otherwise rear value inserting the elements, then rear value will increment by 1. So A of rear equal to element, that is already we discussed. So first front equal to minus 1, here we check the here. So front equal to rear empty, both are empty means minus 1 minus 1. Now here we are inserting the elements. So 0 0 and rear position is 0, front position is 0, rear position is 1. Front position is 0, rear position is 2. Front position is 0, rear position is 3. Swan, front position is 0, the rear position is size minus 1. So now if you want to insert, then there is no possibility. If you want to remove the element, then front value is move from this location to this location. This is about the Q, NQ, and DQ. And here we have a deletion. So now in deletion, so deleting the element, if rear equal to minus 1, now the stack, the Q is underflow. If rear equal to front, that is the only one element we have, then we can remove the elements because we have a single element, right? Suppose we have more than one element, then front value is incremented by 1, front equal to front plus 1. So now this is the, you observe the table here. So front equal to 0, rear equal to, what is the rear size? Rear equal to n minus 1 or size minus 1. So the front value is incremented by 1. So front equal to front plus 1. Now front equal to 1. So 0th element is removed from the list. Now again, if you want to remove the element, front equal to front plus 1. So that is also removed. Second element is also removed. Third element is also removed. So finally, your Q is empty because we are removing the all elements from the Q. This is the Dequeue operation. And next one, where we are use the queues of pressures, applications of the queues. Now, real world applications. One is the buy it movie ticket and bank ATMs and cashier line in any store. Already that is discussed, ticket booking. And second one is the shopping mall. Okay, shopping mall, we have to follow the line. So first we have one entry and another one is exit. These two are different. So we have two endpoints. One is called entry, other one is called exit. Okay, when you are enter into the mall, so go to the, we pick some items and we buy some items, and next after billing we move to other gate. Other gate means that is called the exit. So this is about the second one. And next one is the in computer science. Okay, that is a generally we discussed. But what about our computer science? Where we are using the queues concept in our computer science. Okay, when a resource is shared among multiple consumers, CPU and disk scheduling and a printer. So you observe here now, in CPU schedulings, we have two types of schedulings. One is the primitive scheduling, another one is the non-primitive scheduling. In primitive scheduling, we follow the that is in primitive preemption, that is called the preemption. Non-primitive, there is no preemption. There is no preemption means the CPU is allocated for only one process at a time. Okay, if that process is completed, then CPU is assigned to the another process. So that is called the non-preemption. So in our first come first serve scheduling is the non-primitive scheduling. In this non-primitive scheduling, the CPU is assigned to the process, right? Suppose 4 processes are there or 3 processes are there, P1, P2, P3. So CPU is allotted for the first one, P1, because P1 is the first process. When the P1 is completed fully, then the CPU is assigned to the another process. That is called the first in out. So, and next one is the disk scheduling. In disk scheduling also contain the first in, first out. So, for example, we have take the printer. So we take some prints, right? We follow the that is the queue manner always. Next one is the handling of interrupts in real-time systems. The interrupts are handled in the same order as they arrive and first come, first served. When the first one is completed, then the CPU is assigned to the second one. Okay, so here we have a pictorial visual representation. In this visual representation, printers take the printout by order only. That is the first in, first out, as well as interrupts also handling by using the first in, first come, first served. So this is the applications of computer science. Now, you observe here, so CPU schedulings are 2 types. One is primitive and non-primitive. Only in non-primitive scheduling directly, it is follow the first come, first served. And coming to primitive scheduling, we have a round robin scheduling is there. And round robin scheduling also follow the first come, first served. So that is the in that we have to follow the time slice, time chunk for 2 milliseconds, for 3 milliseconds. But the main objective, main concept is the first come, first served. So these are the applications of the computer science. Once again, we will repeat the all concepts you observe here. So Q is follow the first in, first out. It is a linear data structure. Linear data structure. In linear data structures, Q concept is always follow the first come, first served, or first in, first out. So when the first element is inserted, that element is removed first. So when the element is inserted last, that element is removed last. So that is called last in, last out, or first in, first out. So Q is having 2 endpoints. One is called front, another one is called rear. The front is using for removing the elements from the queue. The rear is using for the inserting the elements into the queue. So you observe here. So another 2 operations are there. That is the display. Already we discussed. Display means you start I value is starting from the front, I value is ending with the rear. So another operation is the peak operation. In peak operation, we have to print the rear value, right? So now endpoints is how many endpoints we have? One is front, another one is rear. So now the insertion is called the Enqueue, deletion is called the Dequeue. So we have 2 endpoints to observe here. The examples are railway ticket booking, and next one is the shopping mall and toll gate. Okay, this is the algorithm for the Enqueue. Okay, Enqueue we have that is called the first one. We check the rear equal to n minus 1. Then there is no possibility to insert the elements. So then for initially front equal to 0, front equal to -1, rear equal to -1. When you are inserting the elements, then we have to increase the front value as well as rear value. That is front equal to 0, rear equal to 0. So in inserting elements, then plus rear. Removing elements plus front. So Dequeue operation. If rear equal to -1, then there is no elements into your queue. For example, front equal to rear equal to -1, then the queue is underflow. Rear equal to n-1, the queue is overflow. You remember these 2 points. One is underflow, another one is the overflow. Overflow means there is no possibility to insert the new elements. Under means there is no elements into your queue. So now you are inserting the elements, rear value is incremented by 1. We are removing the elements, then front value will be incremented by 1. This is the code, programming code for displaying the operation. So you start with the rear equal to -1, the queue is underflow, rear, then I value equal to starting with a 0, zero base front, I less than or equal to rear I plus plus. So now you print the sequential error manner. So this is the queue animation. Front equal to n-1 overflow. Front equal to -1. There is no elements introduced queue, and the rear value will be incremented by 1. Then the element is inserted in the rear. This is the animation for the DQ. We first rear equal to -1 underflow. Front equal to rear, then that is only one element is there. After removing this element, front value is -1, rear value is -1. So finally, front value, if you are removing the element, front equal to front plus 1. Applications already we discussed, and computer applications, you remember these 2 points. One is CPU scheduling, another one is the disk scheduling. And interrupt handlings also follow the first come first served scheduling. This is about the queue. Queue is a linear data structure which contains the two endpoints, front and rear, where the queue is always follow the first come first served, first in first out, or last in last out. The last element is removed last, front element is removed first. So first element is removed first. That's why it is called first in first out. Enqueue is one operation for inserting the elements. Dequeue is another operation for removing the elements. When you are inserting the elements, you simple remember rear value is incremented 1. When you are remove the elements, then we are delete the elements, then front value will be incremented by 1. So this is the main concept of queue. So now next we will discuss the stacks. Okay. Thank you all. Thanks for your cooperation to increase many videos to uploading in YouTube. Thank you all. Yeah, now here you have to check the program. First, initially we have take the int queue of max, and this is the array. Now front equal to -1, rear equal to -1. So now the functions, what are the functions we discussed? One is enqueue, another one is the dequeue. So enqueue, we are inserting the elements. So rear equal to max -1. So max -1, what do you mean by max -1? Now there is no possibility to insert a new element. Queue is overflow. So cannot insert, return. If front equal to -1, you observe here, 11th line, you observe the 11th line, front equal to -1, then front value equal to 0. So initially, if you want to remove the elements, front value equal to 0. Rear value equal to rear plus 1. Rear plus plus means rear equal to rear plus 1. So what is the rear value initially here observe here? Rear equal to -1. So -1. So rear equal to rear plus 1. So now rear value equal to 0. Q of rear equal to Q of 0 equal to element. Q of rear equal Q of 0 equal to item. So the first element is inserted at 0th position. So you display the inserted into the queue item. So what is the item? Suppose I want to enter 10. 10 is in reside at queue of 0th location. So this is the n queue. And function to delete an element from the queue. So now how to delete the element? Suppose front equal to -1, front greater than rear. So there is no possibility like that. So queue is underflow. Queue is underflow means there is no elements in your queue, like it is a empty, right? And next one is we have to remove the key elements. So what is the front value? Now go to the what is the front value? Front equal to 0. So front equal to 0 means that is the first element. So we want to remove the first element by using the queue of front. Queue of front. After removing the elements, front is moved to next position. Front equal to front plus 1. So front plus plus. So now, and next one is the, what is the third operation? Display operation. Front equal to minus 1. So front equal to minus 1, front greater than rear. So there is no possibility. That is the queue is empty. We have some elements are there already. We inserted some elements. So now we display that elements. Right now, queue is elements. What are the queue elements? I value equal to starting value, like y equal to front. I less than or equal to rear, because y I equal to front to initially front equal to 0. If you want to delete that element, then front is moved to next position. So front equal to 1. You print the elements always from the front. Front equal to 0 or front equal to 1, you start from there. I less than or equal to rear, I plus plus. You print the queue of I. So you print the elements. So that is the queue. And next, one more operation already we discussed, that is called peak. So same queue is empty. Now you print the elements. Front element is the first place. That is the peak means first element. So first element, that is called queue of front. And here I want to write the main function. And we have a menu, like we have 4 operations: Enqueue, DQ, display, and one more is peak. And you enter your choice. Now choice equal to 1. We are inserting the elements. So Enqueue of item. And choice equal to 2. We are removing the elements, break. And next choice equal to 3. Display. We are displaying the elements. Choice equal to 4. We print the first element and exiting the program. And default choice is the invalid. So this is about the queue program. You observe here from the first line to last line. Now, first, why you are using stdio.h? Stdio.h is the standard input output dot header file. Now, what is the size here? Max equal to 5. In our example, we discussed 6. So better you write here 6. No problem, any value is acceptable. So you insert the 6 elements. So this is the program. Now, if you want to display, compile and run, I want to share this also. Yeah, now we observe here, enter your choice 1. I want to enter 34 and again 189, 100, 110. So you display the elements, option equal to 3. You display the 34, 89, 100 and 10. Now you want to enter the option equal to 2. Option equal to 2. So you remove the first element, that is the 34. And 3, you print the elements from 89 to 10. 89, 100, 10. Okay, this is the program for the queue. Thank you. Thank you all.